Thank you for joining us today as Anita gives us a perspective on the potential for reducing weed pressure and herbicide input when using cover crops. My name is Odine Alvarez, and I am a soil health educator with the Soil Health Institute. My colleagues Shannon Muller with the Soil Health Institute and Olivia Caluet with the University of Missouri Center for Regenerative Agriculture are also on the call providing technical support. We three support the education component of Farmers for Soil Health. The purpose of today's webinar is to provide you all with insights into practical and research-based strategies that farmers and conservation specialists can use to reduce weed pressure and improve system resilience when using cover crops. Today's webinar is supported by Farmers for Soil Health, or FSH. The initiative is one of many USDA-funded Advancing Markets for Producers projects. FSH is a collaborative initiative of commodity organizations, the United Soybean Board, the National Corn Growers Association, and the National Pork Board, with a goal to increase cover crop adoption. This specific project provides an incentive to farmers uh, who are new to planting cover crops or have been planting cover crops for many years. State-level commodity organizations and conservation professionals work across 20 states, stretching from the Dakotas to the East Coast, to provide local technical assistance and outreach programming. FSH has also developed a website full of resources and information, and you can learn more about FSH at farmersforsoilhealth.com. Lastly, a few items about today's event. This presentation is being recorded, and an email will be sent with a link to the webinar recording posted to the Center for Regenerative Agriculture YouTube channel, along with a final feedback survey. We'll end with a Q&A moderated by Olivia, so as questions come up, please put them in the Q&A. You can upvote questions that you'd like to prioritize as we cover them live. If you run into any technical issues, please don't hesitate to chat the webinar co-host as we will work to resolve any issues. If you'd like captions on, those can be enabled by clicking the three dots on your toolbar and navigating to captions. Be sure to hang on until the end of the webinar so that you can see information related to the Certified Crop Advisor or continuing education units for attending this webinar. With that being said, I'm excited to welcome our guest, Dr. Anita Dille. I'll let Anita introduce herself and take it away.
Thank you so much, Odine. So good morning or good afternoon, depending on where you are. I'm pleased to be here, having gotten this invitation to talk about cover crops and weed management. I'm currently a professor at Kansas State University in Manhattan. My specialty area is weed ecology. I do research and mainly teaching in the area of weed science here in Manhattan. And my goal today will be to talk about how can you strengthen your weed management program when we think of using cover crops. I've been here at K-State for about 26 years and have just seen some really diverse agriculture and changes in the kind of practices that people are using. But weeds always seem to arise to the top and continue to be a challenge. And so I've been intrigued with how we can use cover crops as an approach to one of the other tools that we can use for weed management. And so a bit of an overview of what I would like to discuss with you today during this webinar is to take a tact, an approach, thinking more from what is the weed species that you're wanting to manage. As an ecologist, we always start with what is the weed and thinking of its biology, its ecology, its interaction, and how does that influence the other decisions that we need to make to be able to manage it. Following that, always thinking of how a cover crop is going to fit in the current crop rotation that you may have. So what is preceding that particular cover crop, what will follow the cover crop, and how that influences, the things that you're thinking about in a rotation. And then at the end, once you finally made the decision to include a cover crop, how do you terminate it, and what are some of the impacts related to that? I'll be sharing research work that we've done over the past 10 or so years. A lot of graduate students have come in and explored different pieces of this, and we're starting to see a good picture of how we can use cover crops as a key part of our management program for weeds. And so as I think about what are those target weeds that folks are going after, and of course I'm always thinking or starting with Kansas. And so we are on the western edge of the Corn Belt as we think of some of our corn and soybean systems, but we also have a lot of wheat in our system as we move from east to west and increasing the amount of wheat production that we have. We also have more dryland crops like grain sorghum included in there. And so different weeds become really important problems in those different systems. And so I always ask if I'm getting a chance to actually speak with people, what are the key driver or what are those target weeds that really drive your decisions about weed management in the first place? And then how can we include cover crops to manage that? The challenges with those is that they may have single or multiple herbicide resistance to a number of the products that we've been using. And also, reducing the amount of choices that we have for weed control if we think of the chemical side of things. The other challenge is that they all have very different life cycles. They appear in the field at different times, they grow at different times, and depending on that crop rotation or the choice of crops that you have will have a big impact. And Kansas is kind of, because of the diverse crops that we have different weeds that come in from different geographies that are important. So when we think of Palmer amaranth, that is pretty widespread across the state of Kansas, and we see that as just an increasing troublesome weed all over the Midwest. Water hemp is very much on the eastern third of the state of Kansas and moves into the eastern, mainly into the Corn Belt. Horseweed or mare's tail, depending on the characterization, where you are and what you want to call it, is in our environment a winter annual weed. So it comes up in the fall and will be present throughout the spring. Whereas if you move further into the eastern US, then it tends to be more of a spring emerging weed. And so again, needing to know what weed you're worried about and when does it show up. In Kansas, and we see more of it across this high plains, Great Plains area, is kochia as a very early emerging spring weed. And then again, we're talking mainly broadleaf weeds as concerns where we might consider cover crops in there. But I'll put a question mark there for others if there are key weeds that drive your system in making weed management decisions. Think about that and how a cover crop, how your decision about cover cropping might help manage those. So, what is your targeted weed? The key thing about knowing this is more information on its biology. When does it germinate and when does it emerge in the field? And this has given us guidance as to identifying the best time for a cover crop when you want to set it up, when you want to plant it, and then establish it. And so we have a real flexible cropping season as well in Kansas. In listening to the seminar yesterday, and John Wallace described sort of the mid-Atlantic where growing degree days may be limiting. In Kansas, we tend to have a little more flexibility of a longer growing season and flexibility then and when we can put cover crops in and take them out and have still an impact in weed management. And one of those is we have late summer opportunities. So after winter wheat harvest, there's quite a long fallow period before someone may actually plant another cash crop. And so that gives us an opportunity to have midsummer to late summer cover crops established or the fall and overwintering cover crops. And we recommend these as important to get established and in place before we have horseweed that emerges in the fall, kochia in the very early spring, and then any other winter annual weeds that someone might be concerned about. And we have enough flexibility in the spring that we can actually look at late winter and early spring seeded cover crops that we'll be able to put in ahead of usually a late planted corn or a soybean crop in even grain sorghum, which would allow us to get those cover crops established and enough residue to compete against Palmer amaranth, water hemp, and other summer annuals that someone may be concerned about. So we've got sort of opportunities to introduce different cover crops at those different times, but wanting them established in place before those weeds emerge, because that's the key time for that impact. Part of the reason that this really popped out as an important idea We had done some work in looking at cover crops after wheat to be able to compete against kochia, which is a significant weed problem in the western two-thirds of the state, especially when we found that we had glyphosate resistant populations. And so really needed to find some other tools that might be able to help us. And we had both fall seeded cover crops, so those that were established in um, September, October timeframe. And we also compared that to spring seeded cover crops. So if we could get into the field in March and get some cover crops growing, what kind of impact would that have on kochia? Well, when I put a graphic like this together to look at biomass produced by the spring cover crops, our kochia biomass, spring cover crops, it just looked like scattering of dots. We could not see any kind of relationship. Those plants were all coming up together at the same time. And if kochia won, we could not see any impact. But what we could really see was a huge impact of those fall seeded cover crops and the amount of biomass that they could produce in this environment in Western Kansas relative to the amount of kochia biomass that could be produced. And so across the x-axis there, we have amount of biomass in grams per square meter and increasing, and then kochia biomass in grams per square meter, how much kochia was produced. And we had fallow plots with no cover crop, and you can see that that's where the greatest biomass of the kochia was, and then just a dramatic drop as we have different types of potential cover crops and the amount of biomass they produced. We looked at broadleaf fall sown cover crops, so things like a winter canola, um, a lentil, and we just could not get enough biomass to make as much of an impact as if we had a cereal, a winter cereal, in this case, triticale, or a mixture with those broadleaf crops where we could produce enough biomass and significantly drop the amount of kochia biomass that could be produced with those cover crops. And so I think this was a consistent message that John Wallace showed in the webinar that we saw yesterday, and what we are seeing here as well, that we can really produce a certain amount of biomass to make a big impact on what the weed is capable of producing in these particular environments. The kochia, the amount of cover crop biomass that we need in Kansas is a very different amount than what might be needed as you move further east. One, because we don't have as much rainfall to grow as much biomass, but that also means the weeds can't grow as much either. So it's a balance of what the environment can handle, but we still see that significant impact. So again, kochia for us comes up, could be end of February, beginning of March. So again, the idea, I need a cover crop in place beforehand to make a big impact. And so folks have done research. This is a colleague, Rodrigo Worley, who is now at Wisconsin, but he had looked at emergence profiles, we call these, for winter annuals, the graphic on the left side here, and then for summer annuals on the right. And these are based on growing degree days. So again, no matter where you are, in the area where these weeds might be of concern, growing degree days gives you an indication of when they'll start coming up and how quickly they'll emerge. And for the winter annuals on the left, there's a consistent pattern. And in this particular case, the solid red line on the far left is for downy brome. And it's one of the earlier emerging winter annual grasses, for example. The first upright line here is the first day of fall, so mid-September. And we see a number of weeds that have started to emerge at about that window of time. And then we have the first day of winter, so December, and then the first day of spring. But again, you can see the majority of these weeds will have started to emerge early in the fall and have this sort of consistent pattern of which ones are first, which ones are next. And so again, that opportunity to go out into the field and look for those weeds and know if they're going to be a problem in your environment, which ones are first, and these ones you would want to target with an early fall seeded cover crop. The graphic on the right looks at summer annual weeds. And again, from the top to the bottom is sort of a consistent order based on growing degree days and when they'll come up. This was emergence data from Iowa, but again, with growing degree days, you can adjust for where you are. And again, for me, the top of the list there is showing kochia as that really early first weed up, others that are very early emerging ones, then sort of the middle emerging group, which includes a lot of our summer annual grasses, And then the bottom group tends to be late emerging and ones that continue to emerge through the season. So sometimes a lot more difficult to go after with a cover crop because the cover crop uh, biomass will start breaking down and decaying through the season, and these weeds are continually thinking about coming up. In both of these data sets, horseweed is not in the winter annual group in this particular one, and palmer was not really an issue in Iowa when the study was initially done, but you can group palmer in with the other pigweed species here as sort of a little bit later emerging in general, but continue to emerge through the season. So again, I just find it fascinating that there's this consistent pattern of emergence, and that helps guide us when we need to be thinking of what weeds we need or what cover crops we would need in those environments. So with that background information and realizing that we didn't have horseweed data and really wanted to get an understanding of that for Kansas, we had a student that looked from the north to the south part of Kansas and the eastern side over a couple years. And we had placed these rings at the edge of a field to look at horseweed or mare's tail emergence through time, starting in the mid-fall through the spring, and how they survived through the winter. And we saw that again in Kansas over the 2 seasons that we looked at it, the majority of them emerged in the fall. So this line is looking at that first day of December or first day of winter, first day in spring in March. And we clearly see that the majority, even across those locations with growing degree days on the x-axis, that of the emergence, majority of it was in the fall in our environment. So again, wanting to make sure that we get cover crops in place prior to those weeds if we want to see an impact. So knowing what weed you have, our next question is what cover crop will you plant and when? And so there's a lot of resources out there. Folks have favorite cover crops that they're interested in. When I think of weed suppression, we generally go towards a cereal of some sort. So that could be cereal rye, triticale, could even be wheat. And then again, we have winter and spring varieties of barley and oat that also might be useful for cover crops. And so again, need to be thinking of the crop rotation that an individual is involved in and where will that cover crop fit. And as I have visited over time with growers in Kansas, we've realized that some of them actually have shifted to changing the rotation that they have in order to fit that cover crop in there. And so again, I mentioned, and many people are familiar with Kansas as the wheat state and maybe a dominated wheat rotation. And people have shifted away from wheat in the sense of how much they have to manage that fallow period and how can they grow other crops and build that cover crop residue and maybe not have to go as many passes. So change the rotation from a wheat dominated to something else with more other crops in there. And especially in a no-till environment where we can save more moisture from one season to the next and be able to benefit crops that need more water to grow and be able to do that. The other interesting thing as I visited with growers is they changed their time of crop planting in order to fit the cover crop in there. So again, a little out of the box thinking, depending where you are, what's flexible in your environment. But in Kansas, we have an opportunity to either plant corn early to beat the heat that we experience in the summer, or you could plant it a little bit later. And we have growers planting corn in June to beat the heat, but they can still finish it in the fall. And this opens that window of when they could put a cover crop in that summer, or I should say in the spring season, and then put their corn or their beans into that field a little bit later. So think a little out of the box sometimes to fit that cover crop in there if that's an important piece of your rotation as well as the weeds that you're wanting to manage. The goal again, establish that cover crop prior to that time in the life cycle of the weed for its greatest suppression. We know that a residue or the living mulch itself can reduce the amount of light reaching the soil surface. Many of our weed seeds require a flash of light, especially the small seeded weeds, in order to know they're near the soil surface to germinate and proceed. And so by having that mulch there, we reduce the amount of light and that trigger that they'll be exposed to. We also know that having that residue and that mulch on the soil surface will change the microenvironment that the weed seeds are going to experience. So usually more moisture but a cooler temperature. And so the cooler temperatures, again, tied to growing degree days, will potentially delay when those weed seeds are thinking of being successful to germinate. And some of the other cover crops that folks may choose may also release chemicals from the roots or the decaying tissue. For example, we know cereal rye has this potential, and those chemicals may last a couple weeks from the time of decay or the time of termination to give some weed seed germination reductions as well. And so just to show a couple pictures, another student was also interested in cover crops on Palmer amaranth prior to soybean. And so these are contrasting a picture of no cover. This is already Palmer amaranth growing pretty well on May 13th in this particular field compared to a winter wheat cover crop that we terminated prior to seed production. And then when we look at that field 2 months later, just the dramatic difference in sort of the conditions of the soil and the quality of the beans that are in there. So the top one, no cover, very, very bare. And so folks that are into cover crops get excited when we see these kind of winter wheat residues that's still there and the beans are still producing well. Just to show some of the data related to this, the graphic on the left talks about the amount of Palmer amaranth biomass that each plant could produce across a range of different cover crop studies, as well as the density. And so we've often used the word suppression for weed management using cover crops, and suppression for me means I have fewer weeds, so less density, as well as smaller plants, so less biomass. So it may not be controlled, but we're definitely seeing a reduction in the impact of the weeds that we may be experiencing when we're using a cover crop. So the graphic on the left is the no cover that we were looking at earlier and the wheat, as well as we compared a spring oat, a spring pea, and then a mixture of the two. The red line highlights the amount of biomass per plant produced. So compared to the no cover, we clearly had smaller weeds in each of the different cover crops that we were looking at. And we could reduce the density just with the wheat by 50%, and even with the other cover crops, at least 50% or more. So the number of weeds we needed to manage was less, and the size of those weeds was much less. The amount of cover crop biomass at that time we terminated it before soybean planting just highlights that the wheat was sort of our maximum amount of biomass, and not quite 4 ton per acre with just under 1,000 grams per square meter. So that equivalency there. The peas had potential, but we were still learning on how to get them established in the field. So we didn't produce near as much, but the oat, spring oat, and the pea oat mix still produced quite a bit of biomass, as we could see them having an impact on the biomass and the density of the Palmer amaranth in this particular study. So that's always my goal. And what I've seen in general across a lot of studies, I can reduce the density by about 50%, and I can reduce my biomass of those weeds upwards to 80 to 90% that we need to manage in the cover crop scenario. The other interesting thing is, when did these Palmer amaranth plants actually show up once we got into the crop after we terminated these cover crops? And so this is a graph that shows Palmer amaranth emergence over time with the different cover crops. And so this study, we started with April 1 through August 1st. The black line represents the no cover emergence profile. The blue lines represent the pea in the mix, and the red line represents the cereals of wheat and oat. At 50% emergence, we saw that the no cover reached that 50% target mid-May. With the cover crop, we could delay when 50% of those weeds were up by almost a month. And so again, John highlighted this in his presentation yesterday, but that we can see fewer of the weeds, but also a delay in when they're going to come up, and opening up that window in the soybean crop of when we need to go in and do a post-emergence control of those weeds. And not just when they came up, but they'd be smaller in their size because of that delay and the interaction with the cover crop. And so this just gives us some of those extra benefits in opening up our window for weed management when we think of including cover crops in our system. We have also looked at a diversity of cover crops prior to corn in our system. And the other question that a lot of folks are having is when? How soon beforehand do we need to terminate the cover crop? What kind of impact does that have on the weeds that I see at time of termination, as well as the time of planting? And so this was looking at whether it was just triticale or a triticale plus P or a P um, that were winter sown, so sown in the winter prior to planting corn. And so just showing what kind of biomass production we would have. This is now shifted into kilos per hectare, but about 230 grams per square meter would be the translation. And so this was what the peas look like, hoping to get some nitrogen benefit into the corn at planting time. This was triticale that we were looking at planting time. This is triticale and pea mixture that was terminated about 3 weeks before planting. And so again, not near as much residue that's laying there compared to at planting, and just really looking at, more growers interested in this at planting termination time and what kind of, how much more biomass we can produce and what kind of benefit we can get for weed management. And the contrast is to this no cover at planting burn down application. And this green in this field is Palmer amaranth emerging at the time that we were going to plant no cover crop, just a significant infestation and a challenge to manage. And we clearly saw significant reductions in these other cover crop treatments. So let me show you a couple tables with the data that support what you see in those pictures. So this is looking at the amount of biomass that these different cover crops could produce depending on terminating at 3 weeks before planting the corn or at planting over 2 years. So in Manhattan, one study in 19, the next one in 2020. And we had a full mix of pea and triticale that we could produce quite a bit of biomass if we delayed 3 weeks at planting. But even triticale 3 weeks beforehand could produce a lot of biomass. And we did not have data for a triticale at plant measure in this particular year. Again, in the second year, a significant amount of biomass that we could produce for a successful application with a full mix, so triticale and peas together. How did this translate into weeds that we observed? This is the weed density measured just before we planted. With no cover, we clearly have more weeds, especially at planting. We had about 100 plants in a square meter area. With a full mix or with triticale, we could see that we were getting no weeds emerging. So either they hadn't started emerging yet because they were under the cover, moister environment, but cooler. And also then once we got to the at planting time, we dramatically reduced the number of weeds that we needed to manage in that particular system by the time we were looking to plant corn in this environment. Another way to look at it, this again is in the second year, and we had weed density along the X or the Y axis with increasing cover crop biomass from that triticale or mix. The green and the orange bars just highlight the timing of when those cover crops were terminated. And so as we could grow them longer at planting, the green highlights just how much more biomass we could get and how much fewer weeds we could observe in the field, especially with this Palmer amaranth population that we had there. And so again, the more biomass, the fewer weeds, and also the smaller that they were. And for a grower to manage those now, that's a lot more palatable and more successful with whatever herbicide program they might explore. So awesome. We finally have a target weed that we're going after. We know sort of what our crop rotation will look like. We've got a cover crop growing. Well, now we need to know how to terminate it and when. And so that was, some of the information we just saw. But we need to think about how to terminate in regards to both cover crop and its successful, do we use a herbicide program or some other mechanical kind of tool to be able to do that. But we also need to think of what weeds may be there or what is going to get emerged. So based on that target weed that you're worried about. Of course, we know some cover crops will freeze out. Some need specific timing and methods like cereal rye before you end up, or even any of our cereals. We don't want them to produce seed to be then a volunteer contaminant in our cash crop. So we want to make sure that we're timing those correctly. And we also recommend, and this was also mentioned with John's presentation yesterday, to include not just the termination of the cover crop, but can we include a soil residual herbicide that will then carry us into the early season of the cash crop in order to make sure that we're not letting weeds come up at the same time as our cash crop and competing for the season. There is a standard recommendation that has been out there that says, hey, at least 2 weeks prior to planting, but we see that that opens up a big window of some of these weeds that they also will like to come up during that time frame. And so we also need to make sure that we're matching termination timings relevant to our insurance providers or some of the recommendations, but we're exploring other options. So how can we help improve some of those decisions? So this is NRCS cover crop guidelines. This was a version that's put out in 2019. Most of the Eastern Seaboard is in the same zone 4 where we can terminate the cover crop before crop emergence. But as I look at Kansas, we've got all 4 zones here in the state. And so we are intrigued with how well do those fit the recommendations as we continue to do work, and when do we need to terminate these to minimize any impacts on our cash crop. So we've been doing some more work to refine what that is. And so another graduate student had looked at what happens with residual herbicides that may or may not also have activity on the green plant material when I mix it in with my burn down application to terminate my cover crop. So he looked at cover crop treatments by soybean planting date with no cover on the left, a dead cover, so it's terminated early, but 2 weeks before planting, and then applying, say, a residual herbicide. Or if I go green, planting into a green cover crop and terminating with both the burn down herbicide as well as a residual herbicide to see what kind of impact that might have on successful weed control into the season. I've got 2 graphs that I'll show here over 2 different years. And so we were looking at a number of products that had both soil activity, but also foliar activity. So they could interact with the standing cover crop. And what was interesting though, in the no cover crop, saflufenicil or sharpen as a particular herbicide, I think we had so much Palmer amaranth that we did not see a successful weed control. So it was more a fact of a lot of weeds coming up in the no cover compared to better control in either the dead or the growing green cover crop scenario. But as you can see by the letters, most of them are A's, meaning no difference, but clearly different than if I had no control with no cover crop and lots of weeds. And this is 4 weeks after planting. The second year, we saw no statistical differences except again for that non-treated cover crop. So these particular products can be mixed with the burn down application of glyphosate and dicamba to control the cover crop, terminate it, as well as give us some soil applied activity on Palmer amaranth into the soybean crop with some great success. We continue to look at this interaction of dead and living cover crop on farm fields to see, are there losses in regards to the herbicide tying up in the green, but we could not see that with these studies. Termination timing, another one again, do we go with or without a residual herbicide early all the way up to planting? So this is just showing again the kind of cover crop what do we have when we look at a corn crop in this particular case, 20 days after planting the corn. The left picture is showing no cover, but use of a residual. So we had very little weed problem. This was 5 weeks before planting. We terminated with a cover crop, but did not have a residual. 5 weeks was way too early for termination, but we were getting into a wet spring. So this was going to be our normal 3 weeks, but we ended up delaying planting even longer. Lots of weeds popping up. 3 weeks before planting, we were able to get enough biomass and even without a residual, some good weed control. And then clearly with the day of planting, we've got corn coming up in there with a great cover crop residue that's there. And in the end, let me show you the next graph. When we look at weed management, no residual, significant weed problem, almost 200 weeds in a square meter, lots of Palmer amaranth as an issue, significantly reduced, of course, when we include a residual, and even with 1 week and day of planting with a residual, no weeds at that time. But clearly, between a cover and no cover, we could reduce the total number of weeds we needed to manage, but still the pressure in that field was high. So we needed really to include that residual. And then we were getting just about as good or better when we had that cover crop in with the residual herbicide and managing the Palmer amaranth in this situation. We did the same with soybeans, 5 weeks, 3 weeks, and at planting. And clearly, again, just significantly reduced the number of weeds we needed to manage as we terminate later. And we are not seeing any significant impacts on the soybean yield or even on the corn yield in most cases as we've been doing this work. And so we're getting ready to summarize that as Luke finishes up and to highlight what we see with termination timing on weed management and on crop yields. So overall, I always start with this question to any growers is what's your targeted weed and how do you focus on its biology to be able to include the right cover crop? We can usually reduce that density by 50% and biomass by 90 as a general rule of thumb as we think about including that cover crop in there. What's going to be before and what will follow that cover crop. Again, the flexibility we have in Kansas might not translate elsewhere, but thinking out of the box and how can we shorten up those fallow periods, make sure that those cover crops don't become weedy themselves, but that we allow that cover crop to really have a benefit. And of course, how to terminate. In Kansas can go both ways. Either I need to use up moisture. I've got too much in the east, but I don't have enough in the west. How do we optimize that? How do we link up both the foliar herbicides for burn down of the cover crop termination as well as in season and including the residual herbicides in order to complement those two tools, cover crops and herbicides, to do a better job on weed control. We have a lot of interest in our area. If we're going to put cover crops out there and that expense, how can we graze those cover crops? And we need to balance out recommendations of which herbicides do not have an impact on grazing, having animals out there, but also what mixtures and things we might use for grazing. How long do you keep animals on the field? And pull them off so you still get a benefit from your weed suppression goal of a cover crop. Many goals with including cover crops, and for a lot of folks in our area, it's a supplemental grazing resource that a lot of them use, but how do we make sure we also still get weed suppression? Covered a lot of ground, but would love to hear some other questions that folks may have in regards to some of this information. But I think there's some neat things that cover crops can do for us to help with our weed management challenges.
Thank you so much, Anita. A lot of great information in your presentation. Really appreciate you highlighting the power of residuals combined with cover crops, that parallel of increasing biomass, and then how that can stunt the weed pressure. And so with that, we welcome questions from our attendees. You can drop those in the Q&A. Just to get things started, Anita, you mentioned how cover crops have this allelopathic effect. And I know farmers have heard some mixed thoughts on how cover crops may or may not be impacting their cash crop, specifically cereal rye before corn. Wondering if you have any thoughts on that.
Sure. So in regards to what cereal rye can produce from an allelopathic standpoint, there's some neat studies that were done, and I'll summarize them kind of quickly. They have a very persistent residue. And so again, that biomass is something that is really important. So again, we want a lot of biomass. That residue can persist for a long time in the season. And there were folks that did a study and they pulled samples of that residue over time to look at how much allelopathic chemical was still present at each of those. And because it's such a natural product, it really broke down in like 2 weeks. And so from, when we think of terminating cover crops 2 weeks before crop planting, by the time you plant, that that product has decayed so much in that natural environment that really by the time you plant, it's gone. And so, and again, we have done studies where we see a big impact of that allelopathy on small seeds. You don't need a whole lot of concentration to get into a small seed and impact whether it'll even germinate, or if it does, just the affects its growth. Whereas most of our cash crops with corn and soybean, the seed is so large that the concentration that you might find in the soil is very low and very non-impactful. We also explored it with grain sorghum as a seed. It's a little bit bigger than most of our weed seeds, and we did not see any impact of sort of various allele chemicals on its ability to germinate and emerge. And so I think we've got opportunities where we might, that natural chemical decay so fast it doesn't persist long enough to worry about when we get into some of those cash crops.
Great. Really appreciate your thoughts on that. And interesting to see that Kansas does cover all four of those termination zones.
Mm-hmm.
We have a question about cover crop termination as well as the concept of planting green in Kansas. And I'll read this to you.
Okay.
Can you repeat and maybe elaborate a little what you found about yield impacts on soybean and corn when planting green? How late have you terminated without an impact on yield? And how has rainfall availability played a role in that decision making?
So lots of parts to that particular question. So the studies that we are busy summarizing right now have looked at some on-farm studies. So growers had put out cover crops. We went in and terminated it really early to try to create a no cover. And then we looked at 2 weeks before, at planting, and 1 week after. And so we've done it with corn, not as many on-farm studies, but several in soybean across the state. And we found for yield that there was really no impact of the termination timing on yield, but again, just where you are in the state and the moisture that you would have available there to produce a soybean crop. We did not see that there was an impact of that. But again, in Kansas, the amount of moisture you have influences the amount of cover crop biomass you're going to produce, one, that at time of termination, and then allowing that, putting the soybean in there, and then hopefully it doing well. So usually it was, environmentally a big picture. Termination timing did not seem to have an impact on even more an impact on that soybean in those particular cases. There's some variability, and again, when you're on farm, you've got more environmental variation than you might say if we did a controlled experiment. But we were looking really just that before to just after impact on the soybeans in those cases. In our corn studies, we've done some more of those. People were really have expressed concerns over stand establishment in cover crops that way, as well as then on yield. And in some of the studies that we had, we did not see that there was any impact on stand in the different termination times, and thus did not really have an impact on yield. If you got every plant, you get an ear, and you have that benefit. The challenge with ours is we had some plots where with or without a residual, and in the no residual plots with a lot of weeds that were coming up, then we saw an impact. So again, just the needing to manage your weeds, the cover crop on its own really did not have a significant impact in majority of the cases. So
Appreciate you elaborating on that and describing what you're seeing there in Kansas. You did mention the biomass difference in Kansas for weed suppression compared to John's recommended 2 tons of dry biomass per acre. I'm curious if you have an idea of what the minimum biomass in Kansas is to see success in weed suppression.
I haven't looked at it that way, and I found that interesting as he shared that. So I've been thinking of what do I have in my data, but I showed that one graphic where you can see that decline with biomass, increase in cover crop biomass and the decline of the weed biomass. And we've been mapping that out for each of our individual studies. And we usually, I don't have a number yet, but again, just as we described, as we move across the state, we just see, such a difference in the moisture conditions to grow a cover crop, which also influences the ability to grow weeds. And so if it's dry, nothing grows. And so we see, a related benefit of both. But I don't have a number yet. So I'm interested with seeing if I can figure what that might be. But, he was seeing, just having a cover crop makes a big difference already in what the weeds are experiencing as they think of germinating and emerging in those environments. And so compared to a fallow, as I've mentioned in a number of these different studies, we see a pretty good reduction of the biomass of the weeds as well as the density. And so I don't know what the magic number is to say what percentage of that we'll have, but that's been pretty consistent. If someone's putting out a standard cover crop, we can get at least that 50% fewer weeds and 90% smaller plants at the time that we need to manage them.
Yeah, we really need these tools in our toolbox with the increase in herbicide resistance. And if anyone was on when Etienne joined us to talk about the National Cover Crop Variety Project, she shared the benefits that come from 1,000 pounds of biomass per acre. And we've got colleagues working on trying to develop a cover crop biomass app. So we'll keep everyone updated when that becomes available. Not seeing any more questions coming in, so I'll go ahead and turn it over to Odine to close us out.
Thank you. Thank you, Olivia. And thank you, all of you, for tuning in today. This has been a great discussion, and we truly appreciate Anita for taking the time to join us. Be sure to check out Farmers for Soil Health, which you can learn more about at farmersforsoilhealth.com. A short survey will pop out once this webinar concludes, and we will greatly appreciate it if you could provide us with your feedback. For those wanting the CEU credit, now is a good time to open the CCA app on your phone and be ready to scan the QR code by selecting Scan Course Code. In the screen, you see that we're also excited to be partnering with the Good Idea Shop Talks to offer three virtual farmer meetups on January 22nd, January 29th, and February 5th. The registration link is in the chat, and we will also be included. This information will also be included in a follow-up email. So please keep a lookout for that follow-up email with the webinar recording and additional resources. And if you have any other questions, please feel free to reach out. Our contact info will be in the screen. Anita, if you can go to the next slide.
Yep.
I think so. I think our info will show up.
Trying to get it to move. Here we go.
Yeah, there we go. Thank you. Yeah, and you can take pictures of that, anyone, if you need our contact info. It's right there. And finally, for those checking or seeking the CCA credit for this webinar, the information will be coming up in the screen. Thank you, Anita. And you may scan the QR code on the screen through the CCA app on your mobile device by selecting Scan Course Code, or you may email Olivia using the contact information provided in the chat. I think Shannon will put that in there. And yeah, just really feel free to reach out if you have any questions. Thank you, Shannon. And we really appreciate, Anita, your time. This was a great presentation, and I learned so much, really. Well, with that, hopefully, well, everyone is getting the time, yeah, to get that information. Thank you for joining us, and we hope to see you next time. Have a great day.